many of you put your hands up when I asked about JavaScript. And JavaScript is a language that prioritizes asynchronous architecture, not nearly as much as PHP does. You've written stuff, I assume, on-click handlers, or set timeouts, or made AJAX requests from JavaScript. And that stuff is reactive. It's event-based. So you can do that stuff because you know how. And the language of PHP allows everything necessary to do that stuff in PHP. It's just not done. There's a myth that you cannot write this because your language doesn't support it or you don't know how, and you can forget about that because it's wrong. The second myth is that there aren't sufficient tools to make this process easier. But you can connect to external services. And a lot of what I'm going to show you, a lot of the tools I'm going to show you, all you need is a curl request to be able to use them to write asynchronous code. That's pretty cool. Or if you have access to PHP 5.5, you can use generators in an interesting way to be able to do asynchronous code. Generators on their own are a whole other topic which I'd love to talk about. And if you're around tomorrow morning, I'm doing a talk on generators then, so save questions for that. Or if you're really keen, talk to me afterwards. But you can use generators with PHP 5.5, and they're awesome. Why wouldn't you? And if you can install extensions, there are so many options for you to ease the writing of asynchronous architectures that's hardly an excuse. Stop thinking you can't write it because the language doesn't support it. Stop thinking you can't write asynchronous code because you don't have the tools to do it, because you do, and they're getting better all the time. The only thing stopping you from writing asynchronous code that you want to write is knowledge, is experience, is try it. That is a horrible picture, that large. There's always a question that arises when someone posts about asynchronous PHP on Reddit or on Twitter or even often at conferences or on join-in forums. And it goes something like this. Well, that wasn't, in this voice exactly. Well, that was an interesting talk, because I can hear the voices in join-in. Well, it was an interesting talk, but React or whatever library I talk about and Node.js aren't really asynchronous. You can't do two things at once. The voice trailed off. There is a difference between asynchronous code, asynchronous execution, and concurrent execution. I assume you all have some concept of synchronous execution because as traditional PHP developers, that's what we're used to. A web request comes into Apache or Nginx. We get data out of that, whether it's URL variables or form-posted variables. We fetch stuff from a database. We render that stuff into a view. We return that to a browser. All of those tend to be blocking operations in the code we write. We're used to that stuff, okay? Asynchronous doesn't mean that stuff can execute at the same time. It means those same blocking operations, or operations that have the potential to block, are interpolated. A little piece of processing power is given to each task until all tasks are done. That's what asynchronous is. It kind of goes in a loop. Take task 1, do a little bit of work. Take task 2, do a little bit of work. Take task 3, do a little bit of work. And the purpose of that is so that we don't spend the CPU time waiting for blocking synchronous actions to happen. Concurrency is a totally different thing. Where asynchronous is interpolation, a little bit of each task at a time, concurrency is multiple things at the same time. And your architecture and the platforms you code for need to support this kind of thing. But let me give you an example of this. Asynchronous is like receiving multiple HTTP requests to your application. If you've written it asynchronously, you can do a little bit of work for each of those requests. And requests added right at the end of the queue. Don't wait for everything else to be done first. If you've written concurrent code, everything can happen at the same time. You can do multiple things at once. That means shoving work off into extra CPU cores, or putting them on a different machine, or putting them on a different network, getting things to happen at the same time. That's concurrency. So some things I show you will be asynchronous in nature, some things will be concurrent in nature, and I'll try and point them out as I get along. But don't think that because this code, all of which I show you, can't all do concurrent code, that it's a waste of time. It's not. It's great. You can do it. It's fine. We'll be okay. The first thing I want to show you is forking. This is the simplest form of concurrent execution that you can do. I'm going to show you some code for this. Bear with me, it's kind of technical. But it'll be fine. Let's go over to trusty Atom. We can create a file. I'll call this child, because first we want to get some functionality that we can run separately to the main thread. Okay, so we'll just make a PHP file here. And do something really simple, like touch a file. When we run this, what we expect, if you look at this column on the left, we should see a file there called file after we run this. So let's head over to the console, This was called child. Runs very quickly. There's a file. Okay, we have a child script we can test with. The parent script's where the technical stuff comes. I apologize, try and stick with parent.php. We have to use a very special construct here that's available in certain versions of PHP. You can say exec php child.php. Take a moment to digest. I know it's technical. But if we run this, and maybe we should first delete this file just to make sure it happens correctly. If we run this, we have a file there. Exec. I know, right? You can do concurrent stuff with tools that are in the language and have been in the language for a long time. The excuse of, well, the language doesn't support asynchronous or the language doesn't support concurrent doesn't hold up. Because here we see, we can do it. Maybe it's ugly. Maybe it uses exec. And if you're planning to use exec, think twice, because it's a dangerous thing to use. But there are secure ways to do this kind of thing if your application needs it. Supported by the language, right? If you want to get all fancy pants, you can use something like PCNTL. This installs with PHP version 5. I'm not sure if it's enabled by default on every system, but it's enabled most of the time. It's very easy to check. If that function exists, it's enabled on your machine. When you call PCNTL fork, wow. When you call PCNTL fork, what gets assigned to PID is different, because at that moment, the parent process is copied into a child context. So if PID in this case, after you call that method, is a number other than 0, you are still in the parent process. If it is 0, you're in the child process, which is how we can do fpid to determine where we are. And whatever you exit the script with, the child process, you can get it in this variable. So if you exit with 0, everything went fine. You don't have to do anything. If you exit with another code, well, you can react to that. But this is pretty well supported. There are some caveats with this. When I did exec to run a child script, the parent script blocked until the child was done. The same is true of this. You have to keep the parent script running until the child is finished, or you're going to have orphan or rogue processes, or things will just generally blow up. So the parent script is still blocking, but the child processes are concurrent. They're asynchronous. You can run many child processes with exec or with PCNTL, and they can all happen at the same time, truly concurrent, but the parent still has to block. We'll look at different ways of getting around this. The next thing I want to look at is message queues. Who went to Taylor's talk earlier? It was pretty cool. Like 3 people. You guys missed out. Message queues. Message queues work as a kind of in-memory storage, a place to store a list of data. And we'll look at a few examples of these, and then I'll talk about practicalities of this just now. The first example is a library called Beanstalk. It's a PHP wrapper around the Beanstalk thing. You can connect to an IP address. This is just local at the moment with a default port. You use a specific named container, in this case conference, and you put some data in it. Conference now has a list of items, a list with one item in it, some data, a string. To get that data off, you connect in the same way. You watch that named container, and I guess reserve the right to pull stuff off it. Not sure where that function name came from, but you can get data from it. You have to remember to delete the item or it's going to stay in the message queue. Now, can you think of useful practical ways to use this kind of thing? Whether you use a different language, a different platform, a different network node, you can store data from one node in this message queue and pull it down from another node, which means you can transfer context over a network or over processes and be able to do significant processing out of the main request response cycle. Another library I like to use, another message queue library I like to use is ZenQ. I don't think it's just a message queue library, but this is the only thing I use it for. You create sockets, you connect to something, and you send data. It's pretty similar to Beanstalk. I don't think it ships with a default implementation of named containers. Who cares? Use it anyway. To get data off, you use something very similar as with Beanstalk. And there are other options that you can do as well. If you don't like Beanstalk, if you don't like ZeroMQ, you can use RabbitMQ. These three are Beanstalk, ZeroMQ, and RabbitMQ are examples of local services that you can run. So you download some stuff, you run a daemon, and that gets the data from one place to another. The bottom two, Amazon SQS and IronQ, are web services that you can push data to. They're message queues as a service services. And they're pretty cool. Then there's Gearman. Hands up if you've heard of Gearman. Yeah, it's pretty cool. Hands up if you've used it for something significant. Many fewer people, but awesome still. Gearman has a very nice API to do a kind of concurrent processing with a lot of caveats I'll talk about. You create a client, you add a server which this client will use to connect to. You can add some callbacks. There are 6 or 7 you can use. I've just got examples of created or complete, but there are things like on exception, on progress, on started. There's lots of them. You add a task, and then you run all tasks. And this creates a kind of infinite loop. A kind of infinite loop in some situations. But this add task function, the very first parameter, is the name of a function you want this task to run. We'll see how that's defined just now. It's not a normal PHP function, really. But the second and the third parameter are just data that you pass back and forward. They're called payload and context, but interchangeable. You can use them how you like. When you add this task to the client, this task's data is stored in the Gearman daemon that's running. And you can have a worker that runs at the same time that connects to that daemon, that defines the function that the task is looking for, and keeps working. This is perhaps a deceptive function name, because you may be tempted to think that work is only going to return true in the event that there are still tasks being run or to be run. Work will return true while the Gearman daemon is running and this is connected to it. So if something goes wrong with a task, well, if it's not successful, you can debug, you can restart the process, you can do what you want there. But this is a very nice API to be able to do client and worker stuff, or manager and worker stuff, to be able to do concurrent execution. Those caveats I spoke about. When you use callbacks and you use add task, what you're doing is you're adding a task to Gearman in such a way that Gearman runs as a blocking process. Until this task is complete, these won't get called and this won't stop. So you can run Gearman and you can have blocking stuff done and you can have nice callbacks. Or you can use a function called add background task and variations of that for different priority to add it in an asynchronous way, to manage it in an asynchronous way. But the moment you do that, the callbacks don't work anymore. And think about it. If your client is trying to do stuff in a non-blocking way, once it's issued all the function calls it needs to issue, there's no reason for it to carry on blocking. It can stop. So when you run the script, the moment it's added the task, it stops processing the script. The script dies. Then the worker processes the task, and now it's got some data to give. Where does it give? The client script's no longer running. You can use Gearman as a blocking process worker, or you can use Gearman as a non-blocking message queue worker. And for me, it feels like a mix between the fork stuff, or the PCNTL fork stuff we saw earlier, and message queues, just with a really nice API. But there's no reason you have to use it. You can use a message queue, you can implement your own clients and worker code, and not need Gearman, and have exactly the same benefits. Maybe that's an idea. Another thing I want to talk about is this idea of an asynchronous standard library. Now, this isn't actually a thing, so don't go Googling. And not even the name is a thing. I made it up for this slide. But there are a number of projects that are becoming really popular at the moment that contain a ton of libraries to do asynchronous stuff, where the core PHP function set falls short. So, I'll talk about them. I want to mention one first, while not talking very, very much about it. React PHP is a real thing, and you can go and check it out on GitHub. But I'm not going to talk a lot about it. It was the first experience that I had with doing reactive stuff. It's event loop based, along with the other thing I'm going to talk about. But, and it's got a lot of cool libraries, but I just don't like it. I like the other thing better. That other thing is icicle. I don't know why I'm pointing there when I click, when that's where I need to click to. It's pretty odd. It's like some mental thing going on. Icicle is the other thing I'm going to talk about. This is very similar to the React code base, except for a few important things. It's a lot newer, and it uses generators as the underlying principle for how it structures code. Now again, I'm not going to talk about generators.